So we've learned a tremendous amount about these things we call cataclysmic variables in the sky. We seem to have a model where you've got a big puffy red star donating material to a very compact white dwarf, and that in the process there's a lot of energy released, and that material spins up and creates what we call an accretion disk. So this is an interesting and seems like a plausible scenario we've pieced together, but I wouldn't say we've solved all the mysteries.
Yeah, I mean, one puzzle is how we actually get the situation in the first place. We need to put a star that's at the end of its life and is puffing up to become a red giant very close to a white dwarf. And a white dwarf is, of course, a star that's already died. So how are we going to get these two so close to each other?
Well, it's kind of interesting and maybe not realized by the average person that the average star in the universe is not born like our sun as a single star. It's born as a binary. And remember, that star that was a white dwarf at some point had to puff up to become a very big red giant star as it was running out of its nuclear fuel in its core. And when a big star puffs up, there's going to likely be an interaction because the star, instead of being, the size of the sun, is really going out to the orbit of Mars or the Earth. So you have a great chance for when those things happen, for there to be mass transfer interactions that affect the entire system, where you will, for example, when those two stars are orbiting each other and one puffs up, that will tend to cause a lot of friction and cause the stars to become even closer in the future. And you could expect this not to be a rare event, but happening maybe 5 to 10% of all stars. Indeed, if you look at one of the closest stars in the sky, Sirius has this, as we know, a really nearby white dwarf. And that star almost certainly interacted with Sirius at some point in the past. And so this type of event may well happen for one of the closest stars in the sky, Sirius, in the future.
Yep, so it would have started off as two perfectly normal, perhaps sun-like stars, and then whichever one was more massive would die first and expand. And while it was very big, the dynamical friction would pull the things together. They might even actually orbit inside the atmospheres of each other at some point, so-called common envelope accretion. Then that one dies to a white dwarf, and then at some later stage the other one comes. So indeed this could happen when Sirius A at some point in the future comes to the end of its life and starts swelling up. We might get one of these dwarf V cataclysmic variables right there, very close to us.
Yes. One question that still remains, though, the whole reason we're talking about these things is because they're cataclysmic variables. They were discovered because essentially a new star appeared. And our model, we haven't really talked about what causes that cataclysm.
Yeah, and in fact that's probably one of the unsolved mysteries of the universe. As no one is actually quite sure what causes these explosions. The current best guess is that you get the gas moving from the red star into the accretion disk via the hotspot, and probably the accretion disk gets denser and denser and denser, but there isn't enough viscosity to cause the stuff to spiral in. And at some point it becomes so dense and so hot that something changes in the disk, some sort of instability. Maybe it becomes ionized, and then magnetic field lines can cause the gas to spiral in. And then suddenly huge amounts of gas moves down towards the centre, releasing its energy, producing a very bright, very dense phase for a little while, until the disk has emptied itself out. Most of the gases end up on the white dwarf in the middle, and you have a very thin disk, and the whole process can start again. More and more gas will start.
So it's sort of like the straw that breaks the camel's back in some way, where you have something preventing the material going onto the star, some physical process, and you're piling stuff up. You overwhelm that process, you sort of dump the stuff, and then once that happens, the thing builds back up and the whole process repeats.
Yeah, that's our current best guess. Some people would still suggest that maybe it's actually something in the red star that's doing it. There's some instability there that will cause the flow to suddenly increase. But I think most people currently think it's probably an instability in the accretion disk that's making it happen.
What's quite remarkable about these objects is they're not rare. We see them quite, all over the sky, and we're discovering new ones all the time. Indeed, they're kind of the bane of my existence, because with our Sky Mapper telescope, we're out surveying the cosmos for objects even more violent than cataclysmic variables. And there are so many of these cataclysmic variables that come up that they sort of cause problems. They're almost like a cockroach in the transient universe, because there's so many of them that we kind of just want to sweep to the side because we more or less understand what's going on with them.
Yes, it's kind of interesting because so far these seem like incredibly violent things. White dwarfs are amazing places, way outside any imagination of, say, 19th century people. The incredible densities and pressures and energies of these things. But in fact, they're just the tip of the iceberg of the violent universe. And next time we'll come on to something which is actually considerably nastier and more violent.